Okay, 3.3, proving lines parallel. Well, before we start this section, let's talk about a postulate and a theorem. A postulate is something that is considered assumed or fact, whereas a theorem is something that needs to be proven. So, the converse of the corresponding angles postulate: if corresponding angles are congruent when two lines are cut by a transversal, then the lines are parallel. We already discussed in the last sections that if we had parallel lines, then the transversal would create corresponding angles that were congruent. This is the converse of that statement. So in example 1, if the measure of angle 8 is 110 degrees and the measure of angle 4 is 110, then what do we know about lines L and M? Well, we know that angle 8 and 4 are corresponding angles, and angle 1 and 4 are vertical angles. So that since the measure of angle 8 is congruent to the measure of angle 4, so that was a postulate, something that's considered assumed or fact. A theorem is something that we have to prove. So let's take a look at the converse of the alternate interior angles theorem. If alternate interior angles are congruent when two lines are cut by a transversal, then the lines are parallel. So here's the proof in example 3. We are given that L and M are lines and T is the transversal, and angle 3 is congruent to angle 6. So our first statement will be just repeating the givens. Then we can say angle 3 is congruent to angle 2 because of the vertical angle theorem, and that we know those two measures will be equal. Then we can say angle 2 is congruent to angle 6 because of the transitive property, which says that if A equals B and B equals C, then A equals C. And then now we can say that the two lines are parallel because of the converse of the corresponding angles postulate, which is our axiom or our statement of fact. And what we just did here was a two-column proof, and the idea with a two-column proof is to prove something by making logical statements that can be easily followed. It allows us to make a statement and then give the reason why we can say that, all the way down from the given to the final proof. Example 4. Example 4 is L parallel to M. Well, we know that angle 1 and 109 degrees are a linear pair. Therefore, angle 1 is 71 degrees. Well, that corresponds with the other 71 degrees, so that means that they're parallel by the converse of the corresponding angles postulate. Example 5. What does X have to be to make A parallel to B? Well, the alternate interior angles need to be congruent. So therefore, we must make these two expressions equal to each other and then solve for X. So I set it up as 5x minus 54 equals 3x plus 16. I solve for X and I get 35. To make A parallel to B, X must be 35. Okay. Converse of the alternate exterior angles theorem. If two lines are cut by a transversal and the alternate exterior angles are congruent, then the lines are parallel. Example 6. The map below shows 3 roads in Julio's town. Julio used a surveying tool to measure 2 angles at the intersection in this picture. So this drawing is not to scale. Be careful with something that says not to scale, because the drawing may appear to be something it's not. It might be trying to trick you. So, are these roads parallel? So if the measure of angle A equals 130, then the lines would be parallel because of the converse of the alternate exterior angles theorem. However, angle A plus 40 equals 180 because it's a linear pair. So when we solve for angle A, it's 140, which is not 130. Therefore, the roads are not parallel, even though they may look like it is, not to scale. Converse of the same side interior angles theorem. If two lines are cut by transversal and the same side interior angles are supplementary, then the lines are parallel. Example 7. Is L parallel to M? How do you know? So angles 113 and 67 are same side interior angles, and they add up to be 180 degrees. Therefore, L is parallel to M because of the converse of the same side interior angles theorem. Parallel lines property. If lines L is parallel to M and M is parallel to N, then L is parallel to N. Remember the transitive property of equality. If A equals B and B equals C, then A equals C. So, in our example 8, are lines Q and R parallel? Well, P is parallel to Q because corresponding angles, which is 65, are congruent. P is parallel to R because the alternate exterior angles, which are 115, are congruent. Therefore, we can say that Q is parallel to R because of the parallel lines property, just like the transitive property of equality. Okay, so I hope that makes sense. Try your practice set now.